In this video, we're coming back and we're going to elaborate on something we touched on a little bit in an earlier video, and that is our analysis and design objectives for control systems. So we're going to look at three major objectives, and then we're going to list a couple other sort of minor ones that we're not going to be too concerned about in this class. So our first major objective is to produce the desired transient response. So produce desired transient response. And so of course, we've kind of talked about this terminology a little bit. So we talked about transient response and steady state response. So our transient response is sort of what's going on more close, not necessarily right after, but in the time frame after we've selected and given our input to the system. And then a long time after having received the input, that's when we would be considering steady state. So we want a desired transient response. So a couple things to keep in mind is if our transient response is too fast, we can end up physically damaging the system. So too fast can cause physical damage to system or to other equipment or other people that are in the area. So with each of these major objectives, I want to kind of go back and look at our elevator example that we talked about in a previous video. So if we talk about our elevator and we're talking about a desired transient response, we sort of have two extreme cases. If our elevator is responding too slow, so let's say we pushed our button, we want to go to floor number 4. If it's too slow, then our passengers can become impatient. So of course, that might not be bad if we're talking about on the order of a minute, but of course, let's talk about extreme cases. Maybe it takes an hour to go a floor. So obviously that is far from ideal. The other side of that coin, though, is if our elevator is moving too fast. So if our elevator moves too fast or if it's oscillating, then we can have passenger discomfort, or we could possibly even have injury or damage to our elevator system. So passenger injury, discomfort, and as we talked about above, we can have physical damage to our system. So that's our first major objective. Our second major objective is we want to reduce our steady state error. So we looked at the transient, so now we're looking at the steady state. So reduce steady state error. And so with our elevator example, that was after it's already moved to our desired floor. So let's say we push the button to go to floor 4. So maybe here's sort of our opening. If we're looking at sort of a cross-sectional view, here's our opening for our floor. And maybe our elevator position is not quite aligned with that. So maybe it's a little bit below, but maybe if it's on the order of an inch or 2, it's not going to be too significant. Now, however, if we consider the other case of a larger steady state error, and maybe our error is such that our elevator position is off by a foot or more, that's pretty noticeable and probably something that we're going to need to correct. Our third major objective in analysis and design is to achieve system stability. And so of course that should sound pretty obvious. Of course we want our system to be stable. And so we're going to come back and we're going to define this in a little more detail later on. But in general, we can say that for a system, we have some total response, which is comprised of a natural response and a forced response. So we have some natural response, which is being added to some forced response. And so again, we're going to come back to this a little bit later, but if we want our system to be stable, then this natural response is essentially going to have to go away as our time goes on. So for stability, our natural response needs to eventually, so we're not necessarily given a time limit just yet because it's going to depend on our system, but eventually we need this to eventually decay to 0 or oscillate. And so in most cases, we're going to want that to decay to 0, so go away so that we're just left with our forced response. But in certain situations, controlled oscillation is okay. Now, if our response is growing without bound, that's when our system is unstable. So if our total response, or our natural response rather, which is going to dominate our total response, if it's growing without bound, that's when our system becomes unstable. And so for each of these three major design objectives, our transient response, our steady state error, our system stability, we're going to come back later in the course and we're going to have a whole unit dedicated to each of those three objectives. Now, of course, there are some other things that we need to consider when we're designing a system. For instance, we need to consider our hardware selection. And of course, we can't fit all of this stuff into a single semester, but it's good for you to at least be aware that there are other things you need to consider. And some of these are pretty obvious. So hardware selection, of course, we want to select hardware if we're talking about electrical circuits rather. We need to make sure that our components can handle the appropriate power or current that it's going to be seeing. For mechanical systems, we want to make sure that our components can handle the required force, etc. So there's various requirements that we want to consider when we're selecting our hardware. Another one would be cost. And so oftentimes there's kind of a trade-off between these two things. So for instance, if we want something that can handle a certain amount of force, we could get something that could handle a much greater force, but that's usually going to be an increased cost. So we kind of need to find that nice balance between meeting our needs, but not sort of over-designing. Another thing that is often very important, but we're not really going to consider too much in this class, is robustness of our design. So of course we want it to be able to stand up, behave, operate as intended over time, and in whatever conditions it's going to be operating in. So all of these things are also important, but we're not going to give them as much focus in this course.